In today's vodcast, we're taking a bit of a tangent away from reproduction, and we're going to look at negative feedback. The reason why we're doing this is because negative feedback is a very, very important part of the human reproductive system, both in the male reproductive system and in the female reproductive system. So we need to learn this in order to understand these two reproductive systems. And also, before we do that, we're going to be learning about negative feedback in other parts of the body too, but that's not going to be in this vodcast. This vodcast is just on negative feedback mechanisms and on dynamic equilibrium, and how both of these are very important in obtaining and maintaining homeostasis. First, the definition of dynamic equilibrium. We have homeostasis, which we've had many times before, and that's just keeping the body stable. And dynamic equilibrium is one way of maintaining it. There are two things which seem to be paradoxical or contradictory in there. Dynamic, which means changing, and equilibrium, which means stable. What happens in dynamic equilibrium is that the system as a whole remains stable, but the parts of it are changing. I'm going to show you right now in a demonstration of showing dynamic equilibrium in the water level of a funnel.
Here's an example of dynamic equilibrium. We're going to show that with the water level in the funnel. Now, if we can just zoom in here. Now I'm pouring water in here, and you see it goes. If I keep the water level being the same, you see that's equilibrium. The state of the system stays the same, even though the water in there is constantly changing. The amount of water going in equals the amount of water going out. That's dynamic equilibrium. What's in there is changing, and lost a bit of equilibrium there. And you see how fine a measure it is. That's our whole body is sort of like this. We're on the edge of a knife, just a little bit off. Slow it right down. Down it goes. Speed it up. It may just overflow.
So in this demo that you just saw, what was changing in there? Well, it was the actual water molecules that were in the funnel. That was changing constantly. The water that was in there at the beginning of the demo, none of that water was there at the end, because it was a funnel and water is always coming out. So how is the overall system staying the same? Well, the water level remains the same in the funnel because the rate of water going in is equal to the rate of water going out, so the level of the water in the funnel remain the same. Now we come to negative feedback, which is a way that dynamic equilibrium is kept in our body. The homeostasis is maintained in our bodies, maintained on the edge of a knife. If it goes off just a little bit, like say the pH in our blood just goes off a tiny bit, then you could end up becoming very, very sick and you could die. The way negative feedback works is you have a set value, and that's where the equilibrium needs to be kept. And if something happens to push you off of that set value, then negative feedback means that the force goes negatively to the direction that it was. It goes the opposite, and that will return it to the set value. And here's an example of negative feedback. This is how temperature is maintained in your body. We have a set value. Normal body temperature is 98.6 degrees. You can very easily set that off of the edge of that. And if it gets too low, then you'll end up getting hypothermia, and that could eventually lead very easily to death. If the temperature goes too high, then that could end up denaturing proteins in your body, and that will also kill you. So it's very important to keep it around 98.6. But you can very easily bring it up. Run a few laps, and that will make your temperature increase. And then that starts your negative feedback to keep you from getting too hot. And the amount of heat that you produce, if you didn't get rid of that, that could potentially become hot enough to, say, boil water. So your negative feedback is your sweating will reduce your temperatures back to 98.6 degrees Fahrenheit. Because what happens when you sweat is that your sweat evaporates, and the act of evaporation cools you off. One way you can see that is if you take some rubbing alcohol and put it onto, say, your arm, and then just blow on it or just leave it there. It's going to evaporate very, very quickly, and you'll feel it getting very cool. And that's because the active evaporation cools it. You can also go outside in January without your coat, and that will basically bring your body temperature down. A way that you bring it back up is by shivering. And that's the negative feedback. Your temperature goes down. Your negative feedback is to bring it back up to normal. We will also find in many instances in our body that we have a set point and we have to change that set point. One place where you may see this would be, for example, when you're running a lap, your set point for your heartbeat has to speed up in order for you to keep the supply of oxygen and nutrients to your muscles so that you can keep up with the running. And then when you stop running, then your heartbeat has to slow down. So there you're changing your set point. Another place where you change your set point, for example, is if you go back to temperature, is when you have a fever. If you're sick and you raise your set point, that gives you raise your set point to say 100 degrees, 101 degrees, and that will make things very difficult for the pathogen because it may denature their proteins. That's why you basically shiver when you start getting a fever, because your set point has gone up, and so all of a sudden you feel cold because your temperature is below your set point. Here we are at the concluding questions. Number 1, what is dynamic equilibrium? Number 2, why is the water level in a funnel an example of dynamic equilibrium? Number 3, what is negative feedback? Number 4, why is your body temperature an example of negative feedback? Number 5, when you have a fever, why don't you sweat to bring your temperature back down to 98.6? For this, to get your answer, you can figure it back from what we had in the last slide, or you can go back to your notes from the immunity unit, which we just finished. So have a good night, and I'll see you tomorrow.